Thank you. Okay, so let's start. I'm Peleg, as was mentioned. I'm a cloud security research team lead at Varonis. I don't need the slides to know that. Yeah, I like hacking things, breaking things, fixing them, writing music, astrophysics.
And I'm Coby Abrams. I work with Tal at Varonis as a cloud security researcher and also working on IS research. And I have a passion for teaching and specifically teaching cybersecurity. So what's about to happen? First, we're going to talk a little bit about the vulnerability that we found, just how we run it, how it runs, how it works. And then later on in the presentation, we're going to talk a little bit about the methodology, about how we found this vulnerability and how we looked for it and what we did with it. Of course, we'll share with you the different things that we learned along the way, and hope you enjoy.
If there are 3 things you want to take away, 1, we found a cool RC in Postgres databases, and it partially worked in the cloud. 2, you should be looking for vulnerabilities everywhere, on all managed services, not only workloads that are more popular today. And 3, collaborate before running a remote RC during vulnerability research.
Okay, so a little bit of background before we start just on Postgres. PostgreSQL is a relational database. It's open source, it's extendable, so it has a really great platform for writing extensions for it. We really like Postgres, and because it's so common, you can find it on almost any cloud provider out there.
So there are 2 parts to this story. The first is about using Perl to modify environment variables in Postgres sessions. So Postgres has extensions that add functionality to the database, and one type of these extensions are language extensions. Language extensions allow writing custom functions in various programming languages, including SQL, C, Rust, Python, and Perl. Therefore, there are trusted and untrusted languages. So untrusted languages can access the system environment variables. They can open processes, sockets, access the file system. Thus, they can only be run by super users, while trusted languages have limited access to the system. Regular users that aren't super users can only run trusted functions, so they can't access the underlying system of the database. We were able to break that assumption by using the trusted PL/Perl language to modify environment variables, something that only untrusted languages should be able to do. So how does that work? Well, Perl has this magic variable, the env hash map. And it's used to manipulate environment variables, read and write environment variables. This functionality is embedded deep within Perl. So we thought that it wouldn't be overridden by the trusted PL/Perl, and we were right. So by writing a function like this one, we can set the path environment variable of the current Postgres session to whatever value.
Okay, so now at this point, we have a pretty strong primitive, right? We can change environment variables, and usually we can elevate that to code execution. So what we're going to talk about now is how we actually elevated that into code execution. In order to do that, we used another language extension, also trusted, called PL/Rust. And a little bit about Rust. Rust is a compiled language. So when you're creating a function in Postgres for Rust, Rust needs to have cargo called in order to compile that package, right? So cargo is then going to call the Rust compiler, which is Rust C, in order to create the binaries. And all that is happening when you create a function in Postgres. So that's good for us because when you execute binaries, you're loading environment variables into that binary. So you can see that Rust tried to remove some of the environment variables that we have, right? They're trying to clean the environment so that cargo can run cleanly. but they use the deny list. So you can see here the interesting environment variable that we looked at is called RCE wrapper. And what RCE wrapper does is basically tells Cargo, instead of running the RCE compiler, the Rust compiler, it tells it to run a different binary that's supposed to wrap Rust. Now, we can use that to point it to whatever binary we want, but at this point, we couldn't run that because you can see it's removed from the environment before we run Cargo. Now, a different environment variable that has the same exact effect is not removed. And because it's a deny list, we can change it to utilize it to run any binary that we would like. So this environment is cargo build RCE wrapper. Now, we can't yet control the parameters that are passed to the binary that we run, so we needed to find a different way to inject some kind of bash command. So what we found was Rust, when it's installed, comes with rustgdb, which is a bash script that runs a different environment variable called also rustgdb. So how does this look? Cargo, when we create a plrust function, is going to run either RCE or whatever is in cargo build RCE wrapper. And we're going to point it at the rustgdb script and change the rustgdb parameter to contain whatever code we would like. And that's how we can change the parameters and inject the things that we would like to inject. So let's see this in action. OK, so first we're going to create the different extensions that we need in order for this to run. So we're going to create the plrust extension and the plperl extension. After that, we're going to create a plperl function that's going to change the environment variables that we would like to change. You can see that here. We're changing the cargo RCE wrapper environment variable to point to rustgdb. And we're also going to change the rustgdb parameter so that we can inject bash commands. And then we're just going to create a Perl function, a Rust function, sorry. And that Rust function doesn't need to do anything special. It just needs to be compiled. So when we run the plperl function, it's going to compile the plrust function with our environment variables. And as you'll see in a moment, right, we get some kind of error, but at the end, we have our std out.
Okay, so what's going on? Well, you probably have some questions. How did we find this vulnerability? Why did we choose Perl and Rust? And also, we promised to talk about Cloud RCE. So the idea started after we disclosed a very impactful SQL injection on a database that was hosted on AWS RDS. We wanted to see what impact a real malicious actor could have on a Postgres database. So when you create a database in RDS, Amazon brings you an admin user that, while it can modify the schema and manage data, it's not a super user. So we wanted to find a privilege escalation to gain super user access, or even better, try and execute code on the underlying system. So now we have our objective, running shell commands on Postgres as a non-super user. This is especially interesting in the cloud, since breaking the barrier of trust between the user and the cloud provider and running in areas where the cloud provider is responsible may potentially allow exfiltrating cloud credentials or even moving laterally between cloud customers. So, extensions are a common area to look for vulnerabilities. And we chose Perl. We chose Perl because it's in the official Postgres repo, so it comes built in with lots of Postgres installations. And that means it'll be a bigger impact. It's from the 80s, so there's a lot of code written in Perl. And it's difficult to change all that code. That's before security was really popular, I guess. And Perl has these built-in magic variables. And it's open source, so it's easier to look at. So we have, that's why we chose to look at Perl. And we found that we could use these magic variables in order to change environment variables?
So at this point, right, in our research, we have this primitive where we can change the environment variables. And usually that's really easy to elevate into code execution. Now, the problem that we came into is a difficulty that Postgres actually created. Postgres has an API for extensions to create different processes. So if you want to create a process from an extension, it's not doing that from your own process. It's going to send that to Postmaster, and Postmaster is going to create the process, meaning that the environment variables that you changed, they're not going to be in that new process. So what we needed to find at this point, what we were really looking for is an extension that that runs a binary directly without using this API. This is where GitHub Search and kind of Copilot came to the rescue, right? We're looking for these in open source code, and we just looked for different functions that run binaries. So system or the execv family. We also looked at getenv, right, to see if maybe one of the extensions is loading environment variables in the middle of the process. And in Rust, we search for the command function that creates new processes, and that's how we found out that Rust actually compiles its packages directly within the extension. Now, we promised you a cloud execution, right? So we did briefly run code on a Postgres RDS instance in AWS. Why did we attack our own cloud database? So like Tal said earlier, we were looking to kind of see if we could get some network information, see if we could get cross-tenant access. We were just trying to test for different maybe container escape vulnerabilities that may exist. But what we found was a very limited environment. There wasn't much that we could do. There weren't very many binaries that we could run. And this actually created a problem for us because we couldn't run the Rust GDB script because it relied on some binaries that didn't exist in the RDS instance. So we had to get a little creative, and we ended up using a bash env environment variable, which is just expanded when bash is run to run our code. It's a really cool way to leverage environment variables, I think. And we also found that the AWS incident response team is really, really good. They're really fast. So within a very short amount of time from when we started running code, we had emails, we had LinkedIn messages, we had messages from our CEO who got messages from Amazon. We had all kinds of interactions from Amazon trying to figure out what exactly we were doing, and they also
Collaborate.
Yeah. They also put our instance into the storage failed mode just in case we were threat actors, right? I mean, our database had like information that we were researchers, but just to be safe. So really, really effective. And in the time that we were running, we weren't able to really get any kind of impact, which is why the impact of running this vulnerability on AWS RDS was minimal.
Okay, so we can't leave you without some takeaways. So first of all, if you're managing a database, keep it up to date, of course, especially at least the minor version. All of the minor versions since Postgres 12 have fixes. Least privileges, if you don't need people to create functions, to create extensions, don't let them do that, of course. And limit the extensions that can be loaded. So there's allowed extensions parameter in Postgres that will limit what extensions are allowed. And this is a whitelist, an allow list in this example. In this case, you have anything else? No?
Okay, so something we would also like to leave for cloud providers is managed database backends are kind of prone to these vulnerabilities. This isn't the first time this has happened. You can read the Speckle Umbrella story from Eimear Rad that's really interesting about how he ran code in a similar way on GCP. We also recently found a vulnerability that allows us to run code on Azure Cosmos for PostgreSQL. That was also really interesting. We haven't yet published the information, but we should soon, and you should read about it. But the point is that these databases and these services have these kinds of vulnerabilities, and we need to have some kind of responsible community research, right? We need to be able to have researchers from the community checking these environments, checking to see if we can do the things that we were trying to do, like network access, try to see what kind of credentials we can find, see if there's any cross-tenant access. Really, just in a responsible way, of course, right? We can't just have anybody running code in AWS or in Amazon or Microsoft. But I really think it's important for us to have something like this.
Finally, for us, for researchers, first, environment variables are fun. So look for custom environment variables. They might allow you to run code. And prepare before running code on sensitive systems like AWS. So collaborate with the cloud provider if you're about to enter cloud managed territory. Remember to take pictures along the way. We forgot to take pictures of most of the exploit. Call your database with an indicative name. So we called our database Coby, and that helped AWS contact Coby via LinkedIn. He's apparently the only Coby at Varonis that writes it with a C.
And a Y.
Yeah, and that's how they knew that we were okay. They contacted Coby and asked if our account was being hacked or if it was us. And collaborate. So AWS, we're not too happy about having lots of unexpected alerts appearing just before the weekend. And finally, set your goals before researching. So make an assessment of the potential risks and think what would interest an attacker. This is how we got there. So to summarize, 3 things you should remember. We found a cool RCE on Postgres, and it even kind of worked in the cloud. Look for vulnerabilities everywhere, not only workloads. You might be assuming that something is just static, but everything in the cloud is made of many microservices. There can be vulnerabilities anywhere. And finally, don't exploit on a major cloud service without telling them in advance just before the weekend. Thank you.
Thank you.
Thanks for the talk. I was wondering if you looked at the ASM, like embedding ASM inside of a Rust function or like your extension, because and call a syscall directly using ASM, or is that like banned from the PG Rust?
So both Rust and Perl have some really interesting mitigations in order to turn them into trusted languages. You can't just run anything from Rust. We did look to try to see if we could use any system calls or use any kind of functions, but those are pretty well limited. Perl, the function call that we were able to get was setenv through that hash map. So, yeah.
Anybody else? We got a minute or two. Y'all not awake still? All right, give it up for Coby and Tao.
Thank you.